We are moving into rates and unit rates today. We have done this a little bit previously, but we're going to really get into it this week. So the first thing I want you to do is to complete the common conversions that you should know by 6th grade. So on 1 through number 5, you are going to fill in the blanks with the conversion rate for each thing. For example, how many inches in a foot? And you have about a minute and a half to fill in all of the blanks. Go for it. How many inches in 1 foot? 12. How many feet in a yard? 3. How many grams in a kilogram? 1,000. Kilo means 1,000. How many centimeters in a meter? 100. Centi means 100. And how many quarts in a gallon? 4. You should know these by 6th grade. All right, let's look at the bottom of the next page. And I want you to highlight, circle, square, underline, anything to draw attention to that bottom section, because these are conversions that you will need. We're on page 303, sorry. Anything to draw attention to these conversions, because you will need to memorize them and you will need them for the rest of the lesson. So color, circle, square, highlight, anything you can do to draw attention to them and remember they are there. Huh? It's on the video. They could pull it up. Just saying. I had 12 out of 28. Ever. We are turning to the next page, 304. There we go. All right, so let's talk about measurements and units of measure. When you are measuring things, sometimes they do not all come in the same thing. Like they'll tell you they need the measurement in feet, but they'll give you a whole bunch of inches, yes? Mm-hmm. So let's talk about which one would have a greater numeric value. If I measured a table in feet and in inches, which one would have a higher number? Inches. Why inches? You're right, but can you say it a different way? Can you say it a different way?
Yes, a foot is 12 inches, and it's basically foot times 12.
Okay, can anybody say it a different way? More like Miss McShan's dumb as dirt. Explain it to me. Because I can't with you right now. Because inches are smaller. You need more of them to cover the same amount of space. Yes? So it will have a bigger number because it's smaller. So you're going to do the same thing for B through E. Which one would have a bigger number? And then on number 3, you're going to tell me how you decided that. Any questions? All right, you have about 2 minutes. All right, let's look at this. The length of a table in meter or centimeters, which one would have a larger number? Which one's smaller, a meter or a centimeter? Centimeters, so it would have a bigger number. There are 100 centimeters in 1 meter, so centimeters are definitely smaller. Yes? The length of a table in meter or yards? Iris? Yards. The distance from the school to your house in miles or kilometers? Miles. The weight of your math book in kilograms or pounds? Pounds. So what did you do to decide? Okay, she used the conversion chart on the back of her page and?
I looked back on the ones we previously did. So you looked at your
and determined what?
I chose the smaller.
And figured out which one was smaller. Yes? Why did we try to determine which one was smaller? What did that do for us?
Gives us a good ratio.
The smaller it is, the more we will need to cover the same amount of space, yes? It actually is kilometers. Sorry, I did that one wrong.
Kilomile.
Is it Friday yet? There we go. Better? It's kilometers. If I look at that conversion rate, 1 mile is approximately 2 kilometers. So which one has a bigger number to start with? Kilometers. So that's obviously the smaller one, right? Because you need more smaller ones to make up a larger one. All right, let's look at the bottom. Now we're going to actually work with numbers. And this is where we're going to bring in those fractions that we have been working with. The distance to Toronto is 548 kilometers. About how many miles is that? Well, what conversion did I just write on the board a second ago? 1 mile is approximately 2 kilometers. And what do I know from my problem? 548 kilometers. So what would I multiply by to get there?
2 times.
Figure it out. 2 times what is 548? Noah?
374.
Close. Change the first number. Can y'all put y'all's two answers together?
500.
He said 374. You said 256.
274.
There we go. So we're multiplying times 274. So 1 times 274?
274.
So about 274 miles. So isn't this exactly what we've been doing with ratios and fractions and percents? It's basically just making an equivalent fraction again. What you do to one, you do to the other. Make sense? Good. Then I want you to do B and 5. You have about 3 minutes. Go for it. All right. You order 5 kilograms of food pellets for your guinea pig. About how many pounds are you ordering? So what do I know about kilograms and pounds? What did our conversion tell us? 1 kilogram is about 2 pounds, yes? So, what do I know from my problem?
Because on the bottom is 5 kilograms.
5 kilograms. So I put that even with the kilograms. Kilograms and kilograms should be in the same place, yes? So what do I do to 1 to get to 5? So 2 times 5? 10 pounds. And pounds is LBS for abbreviation. Don't ask me why. I have no idea, but it is. So your answer should have been about 10 pounds. So as far as strategy we used, what did we do?
We looked at our resources and
We used the conversions to make an equivalent fraction or an equivalent rate. Any questions about this one? Okay, let's look at the next page. We are actually moving on to 307, so you're skipping a couple. All right, we have used double number lines before, and we said they can represent fractions because it's basically just putting the line between them and it makes it look like a fraction, yes? So that's what we're going to do. We're not actually going to draw double number lines. We're going to do the fraction setup because that is what we have been using so many times that it should be second nature for you to do that by now. You are baking cookies at your friend's house. You cannot find the measuring cups, but you can find a tablespoon. So using the information from the double number line, that 16 tablespoons is 1 cup. I want you to answer A through D using the fraction method. Are there any questions about what you are doing? You may work as a table, but I'm only giving you about 3 minutes. You are using the fraction method. Got it? All right. What do we know from our double number line about tablespoons and cups? 16 tablespoons is 1 cup. Yes? And what do I know from my problem? 2 cups. So my cups go where my cups are. They're both denominators. All I'm doing is building fractions based on the information that they gave me. The first fraction is my conversion. The second fraction is what they gave me in my problem. Does that make sense? It's not hard, guys. So what am I going to do to that 1 cup to get to 2 cups?
Multiply it by 2.
1 to 2? By 2. So 16 times 2?
32.
32 tablespoons. That's all you're doing.
Yeah.
I'm going to give you a minute and a half to finish the other 3. Yes. Holy cow. Did my conversion change for cups and tablespoons? No, it is 16 tablespoons for 1 cup. Yes? And in my problem, I know I am going to 1 3/4 cup. What do you do to 1 to get to 1 3/4? Of course you can.
Oh, wait, well, my bad. You do what?
You don't have to do that either. Anything times 1 is itself. So if I need 1 3/4, I multiply 1 by 3/4. I don't know why that one is confusing everybody so much. If you're multiplying by 1 is the easiest thing you can do because you're just multiplying it by the number you want.
Oh, except on 0. I think we're just 0 is over. So we're looking for the hard stuff.
All right, you have about another minute to get finished. I started that one for you. Okay, so 16 times 1 3/4 is 28. Let's do that because apparently it's confusing to people. What do I do when I'm multiplying a fraction times a whole number? Put a 1 under it to make it into a fraction. And then I need to make this one improper. 4 times 1 is?
4.
Plus 3?
7.
So I have 16 over 1 times 7 over 4. And I get 112 over 4. Now what am I doing? Simplifying. How many times will 4 go into 112? 28 times. All right. Then we have a 1/2 cup of raisins. Has my conversion rate changed? No. I still have 16 tablespoons for 1 cup. And I'm trying to find 1/2 cup. Yes? So what am I doing from 1 cup to get to 1/2 cup? You can multiply by 1/2 or you can divide by 2. So what is 16 divided by 2? 8 tablespoons. D says, suppose you had found the cup but not the tablespoon. How many cups will you need if the recipe calls for 2 tablespoons of vanilla extract? Has our conversion rate changed? No, it is still 16 tablespoons for 1 cup. Except this time we're doing tablespoons. So it goes at the top. Yes? What would I do to 16 to get to 2? Divide by 8. So 1 cup divided by 8? It's either 1/8 or 0.125 cups. 1/8. Make sense? All right, so I want you to do the bottom, and I'm not going to read this one to you. You may work as a table, and you have about 3 minutes. The only thing I'm going to point out is here is your conversion rate. All right. All right, let's start with our conversion. What do we know about meters and feet?
That 1 meter is 3.28 feet.
And what are they asking us from our problem? What is our length?
5 meters.
5 meters. So what am I doing to 1 to get to 5?
5.
So 3 and 28 hundredths times 5? 16.40 feet. Just that easy. Yes? Again, our conversion rate has not changed. And we're going to 4 meters. So what are we doing? Times 4. So I get 13.12. Pretty sure it's 12.
Yeah.
Make sense? This should be easy peasy. It's just write it out. That's all you got to do. And we're going to 2.5. So we're multiplying by 2.5. That one I can't do in my head. I actually have to work out. I already know that 5 times 3 and 28 hundredths is 1640 because that was letter A's answer. Yes?
Yeah.
So I can cross that out, put my placeholder, and do times 2.
That would be 8.20.
Say that again?
Because if 1 meter is 5, if you have 5 meters, that's 16.40.
Yes, because there are 3 numbers after the decimal, so it's 8.2. Make sense? All right, I want to do 2 more problems before I let you go on your exit ticket. So you are going to page 309. And we're looking at number 4 first. All right, number 4 says the school cafeteria has 8 huge cans of tomato sauce for making pizza. Each can, stop that please, contains 2 gallons of sauce. Is there more or less than 50 liters of sauce in these 8 cans? So first, we need to find our conversion rate, which is at the top of the page. What do we know about liters and gallons from our conversion chart?
1 pound.
We know 1 liter is 0.26 gallons. We also know that 1 gallon is 3.79 liters. Yes? So we have to figure out which one we're going to use. So let's talk about the problem first. It says each can contains 2 gallons of sauce. There are 8 cans. How many gallons is that to begin with? If each can, so we have 1 can, that's 2 gallons. We have another can, that's 2 gallons. We have 8 of them. How many gallons is that in all? 16 gallons. So we need the conversion that will get us to 16 gallons evenly and easily. Are we going to use the 26 hundredths or are we going to use 1? 1. So we don't need this one. We need this one. Does that make sense? So what am I doing to get to 16 gallons? Times 16. So I am multiplying this times 16. Give you about 30 seconds to figure out that answer and tell me, is it more or less than 50 liters? All right. What'd you get? Well, what was our answer for 3.79 liters times 16? Did we actually work it out? Okay, so what was your answer?
I worked at the wrong. I think I didn't do it right.
I had it written on the board.
8.
3 times 16 is 8?
No, oh, 3 times 6.
First of all, if I round this to the nearest whole number, 3 and 79 hundredths turns into what? 4 times 16 is what?
64.
64. So I know it's going to be close to 64. My answer is actually 60 and 64 hundredths. And that's liters. So is that more or less than 50 liters? More. They have more than 50 liters of sauce. Make sense? Guys, it is just making equivalent fractions. I don't know why y'all try to do it different ways. Just do it the way we do it. Got it? All right, take out your Chromebooks. You need a sheet of paper and a pencil because exit tickets are now for a grade. In your Carnegie Learning, you have 2 exit tickets on a playlist for you today. I will tell you the title once you get it out. As long as you're doing the same thing to both numbers. All right, you're also going to need to tear out your homework, which is page 315 and 316. Your exit tickets are labeled Module 2, Topic 3, Lesson 1, Exit Tickets. Please find that in your Carnegie Learning.